Hi, in this video, we will continue to look at exponential functions, where my base, my a, is a fraction, such as half, 2/3, or like 3/10. Okay. So in the previous video, we already looked at this scenario where my base is a value that is greater than 1. But now we'll be looking at the second scenario where my base is a fraction. So let's get started then. Alright, so let's just again, we'll be looking at this from let's look at a few equations. So maybe my f of x is equal to half to the power of x, okay? And another one, say f of x is equal to y over 1 over 3 to the power of x, and let's just go with the two of them, okay? And let's put them in decimals. So I'm going to pause the video and I will put these equations in decimals, okay? Alright, so here I have y is equal to half to the power of x. That is the red line that I have here. This is my half to the power of x. And the black line is 1/3, 1 over 3 to the power of x. The black one is the 1/3 with 1/3 as the base to the power of x. Okay, so it seems like if my base is a proper fraction, then the shape of my exponential function kind of looks more like that, something like that, right? And I'm not sure if you guys noticed. What about the horizontal asymptote? Is it still there? So let's look at the right hand side then. If I zoom in, maybe we should just look at the y is equal to half to the power of x. Okay, so I will hide the black line. So the red line that I have here, it seems like if I go towards the right, the horizontal asymptote will still be there. Right? It gets closer to the x-axis, but it doesn't look like it's ever going to touch. So the horizontal asymptote is still there. So I will have my horizontal asymptote. It's still going to be there. Okay. Now, if you compare what I have here with what I have here, what do you think? There is some sort of geometrical symmetry here. What do you think? Is it possible for me to get from this graph to that graph, or maybe from this graph to that graph through some sort of transformation? Think about it. Okay. So, I hope you guys thought about it. And let's try to do some manipulation with our functions. And I'm going to take f of x is equal to half to the power of x, and f of x is equal to 2x. I'll take them and I'll mess around with them a little bit. So my f of x is equal to 2 to the power of x. And I say I have g of x is equal to half to the power of x. What I want to do now is to somehow convert g of x that will look similar to 2 to the power of x, and then see if we can really do that. So half becomes 2 to the power of -1, right? Because we have a reciprocal, and the power of x is still going to be there. And this becomes some base of 2 to the power of -1, and then to the power of x. So power to the power, I can multiply them, so I get 2 to the power of -x. And my f of x, I'm not going to change that. and let's just compare them. This is my g of x, and my g of x is equal to 2 to the power of negative x, and my f of x is equal to 2 to the power of x. Now, back in chapter 1, when we learned about transformation, what does this thingy, what is that? What type of transformation is that? Maybe you can pause the video, go back to your notes, and think about what type of transformation does that negative give us. Okay, welcome back. I hope your answer was horizontal reflection. Horizontal reflection, which means we're going to reflect across the y-axis. Right? Horizontal reflection across the y-axis, because we're multiplying a negative to the x. So we're going to flip the whole, we will flip, the better word will be, we will reflect f of x, the graph of f of x, across the y-axis. And then if we do that, we can get the graph of g of x. So now let's go back to Desmos and let's verify if that's true. So here, let me bring it back. So this is how y is equal to half x look like. And I'm going to activate y is equal to x, and you can see that they are perfectly symmetrical along the y-axis. In other words, they are the horizontal reflection of each other. Okay, so the transformation stuff that we learned previously in chapter 1, we need to know them. Okay, we must know them. All right. Lastly, a few more terms that I would like to point out. We called graphs that look like this, where as you go to the right, your curve, your graph kind of picks up. It becomes steeper and steeper. We call that exponential growth. Exponential growth. So a lot of times we hear people talking about the population on Earth. It grows exponentially, or we say that the temperature of the planet grows exponentially in a very minor scale, maybe. Right, so we hear it growing exponentially. We hear a lot of people saying that when they're trying to describe things that grow really fast. Right. Now, if this is called exponential growth, then on the left over here, that would be exponential decay. Exponential decay. Okay. So again, that just means that it's gonna decrease really fast. Okay. We will come across these two terms, exponential growth, exponential decay, towards the end of this chapter, where we will talk about word problems. Okay. All right. I hope you guys find this video helpful, and I'll see you in the next video. Bye.